Hi, my name is Rob. I'm building a hypercar, and for that we need an autoclave. So that's what we're building today. Well, not one like that, more like this. So what is an autoclave? There's two types of autoclaves. One is used in the medical professions to clean medical instruments, disinfect them. The other one is used in manufacturing of carbon fiber or composite materials. They are often huge and extremely expensive. In the future, we really will need one that can fit the whole monocoque. For now, we're building a small one from very limited supplies because we want to be able to test and make some small parts to get started. An autoclave for composite manufacturing is an environment with high pressure and low pressure and temperature. And how do we combine those? Well, that's the important part of an autoclave. It's a machine in which we put a part that's all laid up with carbon or fiberglass and the epoxy in a vacuum bag, and we pull a vacuum on that bag. We keep a constant vacuum on that bag. Then the surrounding environment will increase the pressure, the air pressure. That way you have perfect clamping force from every direction on that part. And then, on top of that, we'll heat that environment to a temperature that is perfect for the epoxy or the material around the carbon fiber to set. So today we're building one that's pretty good size. I'll show you the distances and the sizes here in a minute. And that can do pretty much everything you need to do without using so much power or taking so much space or so much money that is prohibitively expensive for at-home use. This one, I don't know exactly what the budget will be, but less than €1,000 for sure. At the end of the video, you should have all the knowledge you need to build one yourself. We'll also be building some software to control the autoclave. How much heat, how fast, how long. We'll show you how that software works and release it on an open source license so you can use it yourselves if you want to build your own. The link to download the software you can find in the comments under this video. This stuff can be dangerous. There's high pressure, high temperature. So if you don't know what you're doing, don't try this at home. Let me explain to you what an autoclave does. So what we have here is a vacuum pump and a vacuum chamber. And while this is the other way around, the opposite of what we're building with an autoclave, I think it shows the concept quite well. What we're going to do here in a minute is I'm going to put a balloon inside the vacuum chamber with a little bit of air in it. So not too big, just a small balloon with just a little bit of air. And then I'll pull a vacuum and you'll see the balloon grow because the pressure inside of the balloon becomes relatively bigger than the pressure inside of the vacuum chamber. If you want a balloon really big, well, you better use a compressor or a pump of some sort because blowing it up with your mouth becomes really tough. That's because the pressure of the atmosphere is pushing down on the balloon from the outside while you're pushing on the inside. What I'm going to show you, if you take that pressure of the atmosphere away by using a vacuum pump, that balloon becomes bigger without having to put more air in. Then if you let the pressure back into the vacuum chamber, just normal atmospheric pressure, the balloon gets back to its original size. It works the same in an autoclave, except there it's not a vacuum chamber. We actually put extra pressure in the chamber of the autoclave. By increasing the pressure on the outside and decreasing the pressure on the inside, we create a uniform pressure on the part to make sure all of the air is out, all of the voids are out, and it becomes as cohesive as possible and as strong as possible. So let me show you how it works. This is in reverse of what an autoclave works, but it shows you the pressure difference. So I've got a regular balloon, nothing special. Well, there's a balloon with just a little bit of air. It's not very tight, so let me tie that off. So let's put the balloon in the vacuum chamber and let's see what happens. Again, soft balloon. Close the vacuum chamber, turn on the pump and open the valve. And as the pressure drops, you'll see that the balloon grows because the relative pressure inside the balloon becomes bigger compared to the pressure in the tank. Well, that's about how much the pump will do. So let's see what happens when we turn it off. So we close the valve, turn off the pump. Now let's see what happens when we let the outside air back in. And as the pressure normalizes to the outside air, we can lift the top off again. And the balloon is back to its old shape. Still not very hard. So let's start building this thing. So we've got the top of what is going to be our pressure system here, and what it is off of, like the pressure pot and this that you just saw in the parts we're using, it is a pressure painting system. So normally you would put a can of paint or a bag of paint in here, put pressure on the outside, and the paint would flow out of this connection. Well, we're going to be using it similar but slightly different. So still, we're going to put pressure on the pot from this connection. So on this connection right here, we'll be connecting the compressor with just a simple air line, normally as you always would. We can adjust the pressure, see the pressure here on the gauge, and do not go beyond the rated pressure. In this case, stay below 60 psi. That's what the pressure pot is rated for. There's also, to make sure that that's secure, there's a safety valve right here. We'll be testing it in a minute, but don't modify that. Don't paint over it, don't put a piece of tape on it, don't remove it, keep it there. It's important. So pressure in here, then here we have the part that's normally used to push the paint out of the pressure pot. We'll be using that to suck the air out. So we'll be connecting an air line from the vacuum pump to here. And using the valves, we'll be able to control how much vacuum we pull, how much pressure there is, let the pressure back in, and so on. So let's put some plumbing fixtures on here and make sure everything hooks up. So let's start with some Teflon tape, rated for air, kind of important, I've been told. Okay, that's one step. Now let's put the hose on. And tighten the hose clamp. Well, now the vacuum pump is connected to the system. Now let's go in on the inside. So we go on the inside. So here is where the air, the pressurized air comes in, and this is normally where the paint hose is attached. Obviously, we want to connect the hose there that we can connect to the vacuum bag. So let's put a connector on there. Got one right here that will allow us to do that. So again, let me put some Teflon tape on there. Well, got some Teflon tape on there. So there we go. These are quick connect fittings. They're similar to what you find on a 3D printer for your filament guides. So we've got some vacuum hose here. Push it in and it's secure. So on the other hand, we want a quick connect fitting that we can connect to our vacuum bag part. We need to connect that to this vacuum hose. So I've got this connector for that. So let me connect those two together. So now let's really tighten this so it doesn't come off again. And now connect that to the other side of the hose, press it in, and done. We now can pull a vacuum on this connector, and you know what? That should work. So let's test if this works. I've got another balloon, and I've connected it to a quick connect fitting. So let's blow it up and connect it to the vacuum pump and see what happens. Well, connected to the vacuum system. Let's turn on the pump and see what happens. Obviously, it's sucking a vacuum quite quickly. And there we go. It's got a full vacuum. Now, if I turn back the valve back and let atmospheric air back in, let's see what happens. So obviously not much happened, but the air came back in and it's just back to a regular balloon. Next step, electrics. For heating the pressure pot, I've selected these silicon pads with heating wire in. They're very low power, 12 volts, 20 watts. So that makes them very safe to use in this environment. So we only have 12 volts going into the pressure chamber. I've got one running here, just a pad with a temperature probe taped to it. Somewhere on the bottom here you can see the thermostat running, so you've got an idea how fast it actually heats, pretty fast. These things are available online from many sellers. I think I got these from Amazon for like 15 or 20 euros for the 4, so they're very cost effective. I think they'll be more than enough to heat our chamber to the 60-65 degrees I'm hoping to get. I'll be taping this to the inside of the chamber. We'll be doing that here in a minute, and obviously connecting them all together. To help keep the temperature uniform in the whole chamber, I'm adding a small fan, also 12 volts, so it can be connected to the same circuit, just to make sure we don't get any hot spots close to where the heating pads are, and just keep the air circulating as much as possible. I think those two things combined will heat the environment sufficiently and be able to get us to the temperature targets that we have. Noisy, but this is the pressure pot we're going to be using. I actually bought this used. It's a one-piece pressure pot, obviously with a lid. The lid we just modified with the vacuum hoses. And if I turn it over a little bit, you'll see that there's a stainless steel insert that normally takes the paint. The only thing I've done off camera is I've added insulation, close foam insulation between the two, so they're not terminally connected anymore. So there shouldn't be any of the heat that we put in the inside should stay on the inside. Obviously that's nice and reflective. And I'll be putting the heating pads on the inside of this together with the fan to get the circulation and the heating we're looking for. So I'm going to be positioning the heating pads somewhere like this on the sides. And then the fan somewhere in the back, like right there in line with one of the heating pads. With the idea that I'll be able to put things upright or this way, and actually we have quite a bit of space. So let me grab a tape measure and I'll show you how big this environment actually is. It is about 30 centimeters across, so about 12 inches, and almost 40 centimeters deep. So that's about 16 inches, a little below. So I can put some pretty big elements in there. Should be enough for most of our suspension parts and maybe some other bracketry and stuff. So I think this environment will be very useful. I think this autoclave will be very useful for what we're doing. So with that said, let me start attaching these and then do the electric connections, and after that we'll get back with you. So I've wired up the whole thing for heating pads and the fan. Fan is temporarily attached just with a little bit of sticky tape. We're editing and we just noticed we're missing the footage for wiring and installation. So if you want to know how we did that and want more details, leave it in the comments and we'll help you out. Just so to check that it all works, I think I may actually attach the fan to the lid so it's movable. Also got a temporary wire to feed it all so we can test it out. Just to stay safe, it is fused. So I think the fuse is a little on the small side, but it should work. So my intention right now is to put a temperature probe in here, turn it right side up, and then see what it does. Turn it on, see what it does, see if it heats up. Hey, perfect. Make sure there's no wires in there. Put the temperature probe somewhere in there. Make sure it's not touching any heating elements. Well, we're not going to put any pressure on it, no vacuum, nothing, so I don't have to tighten it down. But I guess we could start heating it. Let me attach the temperature probe so we can all see what's going on. So let me get some tape. Actually, I think we'll probably position it like somewhere like that. You should be able to read that. Right now, 26.8 centigrade, so that's about 80 Fahrenheit. I'm sure the editor will put the exact numbers down there. So let's turn this on. Well, 12 volts, 6.5 amps, so quite a bit of power. Much more than earlier, but that makes sense with 4 heating elements and the fan in there now. I can hear the fan buzzing. So let's let this run for a couple of minutes and let's see if the temperature goes up. 10 minutes, and from 26 centigrade we went to 40 or even over the 40 degrees centigrade. Doing really well. I'd say this is a very successful test. To control our autoclave, I'm using a little computer, in this case an ESP32C3. It's a tiny process computer. Works very well, they're very inexpensive. To that I attached a temperature sensor, the one that's on the screen right there. They're cheap, they're easy to get everywhere and easy to communicate with because it's a one-wire protocol, so you don't need a lot of communications. Then a relay to turn on and off the heater. On the ESP32, I'm running some software we built ourselves. We wrote some software. It's available on GitHub. The link will be below. Working right here. It's actually running right now. You can see that the chart is going up. You can see the heater is on and the temperature is actually rising steadily. A couple of things that the software can do. On this screen, on a big computer screen, you've got 2 panels. The currently operating panel and the recipe you're currently working on. If you're on a phone, those will be below each other. So we've got a simple recipe right now, just 2 hours at 131 Fahrenheit. That's 55 centigrade. You can program all that, you can store different recipes, and then you can execute them. And there's a chart that shows you what's going on with any potential error messages at the bottom. So the autoclave is ready. It's ready to make parts. So let's lay up some carbon fiber and see what we can make. To do that, I prepared a little bit of chopped strand, a little bit of strand and a piece of woven for a very simple mold. I've pre-waxed the mold. I'm not going to show you how to lay up the part, to do the waxing, do all the other parts. There's plenty of YouTube channels that tell you that. We'll just be back with you when we're ready to put it in the autoclave. So you see me playing around without breathing protection or anything else. Well, actually, if you look at the table, we're on a downdraft table that is currently on. So everything that comes off of here, there's actually no smell here at all. There's no carbon fiber coming in the air. It's all going down through the grate and into the table and being cleaned up. So we're actually working fairly safe. So pack the mold with the carbon fiber and the epoxy, put some release film on top. I waxed the release film just to give me a little bit more chance to get it out. Putting that all in the bag and then getting the vacuum on, the heat on, and of course the pressure, and then we'll see what it bakes. We'll be back in a minute. Now let's fill the autoclave and turn it on. Because it takes a while to warm up, I'll turn on the heater and then I'll come back and put the pressure on, close the machine and turn the pressure on. So it has some extra time to warm up as quick as possible. So I was actually very happy with the vacuum it pulled. That was outstanding. Okay, well, you may hear in the background the vacuum is still running. The heater is on. Actually, let me check. It went up about 6-7 centigrade in the last 2 minutes, so about 10 Fahrenheit. So that's doing really well. So let's put the compressor, let's connect that and see what the pressure does. So you can see the pressure is rising. I'm going to run it at about 3 bars. I think that's enough for what we're doing. The autoclave can actually go up to 4, but I think 3 is more than fine. And then we'll just leave this overnight. I've got the heater set for 6 hours, and then it will slowly decrease in temperature. And then tomorrow we'll check what the part looks like. It's the next day, and well, the first step, the epoxy that I made way too much of is hard as a rock. So let's see what the autoclave did. So we'll put this to the side. Obviously I already opened it up and turned the pump off. First time, looks good. Let's see what we got. Well, I don't know if you can see that on camera, but I think here on the detail shot you can see it. It looks really good. The top is really nice and smooth. Maybe a little dry, but man, I would use that. Let's see. Well, it comes apart. I used a lot of wax, so maybe too much. So you can see the bottom is very waxy, very dirty. I'll clean that up in a minute, but let's see what we can do. Well, I'm not the biggest and strongest guy, but I'm pretty strong, and that's a very strong part. That's definitely something that we can use on the build. So autoclave seems to work. The bottom is a little ugly, so let me clean it up a bit and I'll be back with you and we'll see what it really looks like. Did a little bit of cleanup just with an old rag and some acetone. And man, it looks really nice. It's not perfect, but man, I would use it. I would run this no problem. Obviously, this is just a test piece, right? Just a test cookie, just to see if the environment worked. I'm very happy with it, and could be better, yes, for sure, but we'll get it better as we learn how to work with it. It's got a couple of small voids. I think I turned off the vacuum too fast, but overall, very happy with it, and the autoclave is ready for use. Well, that about wraps up this episode. We can now obviously make pretty good sized parts that fit in the autoclave. I'm very happy with how it works. We've shown you how to build an autoclave, what parts to use, how to put it together, the software you can download to the link under this video. Next episode we're going to be talking about design. Now, if you think, hey, that's a crazy project, I want to see this guy fail, or maybe you want to see us succeed, build your own car, learn something, well, subscribe, tell your friends about us, like, comment, follow us on any platform. It really helps us out to get us some more exposure.